We're going to cover a bit of reactive programming. We're going to cover, at the moment, three architectures that are raised mainly with reactive programming. One is the model view intent that could be applied. Basically, currently the first implementation was made inside Cycle.js. But after that, there is a movement currently. A lot of Android applications are moving to model view intent, and I saw also in Python that they're starting to use that on the server. It's an interesting architecture. Probably is the most reactive one of the threes. In my opinion, it's very smooth. I really like that. I work a lot with Cycle.js. Really like that. Then Mobile State 3, I think you're familiar with that. Vast majority of you. Vlad, you can explain if you want Mobile State 3. And then the SAM pattern, that is another pattern that is fully reactive. The interesting part of SAM pattern that is framework agnostic, therefore it can be used wherever you want, potentially in any language. There is currently one implementation, the one library that's using SAM pattern mainly, but you can use with Angular, React, or wherever you want. It's just a pattern that you can use. So these are the things that we're going to cover. So let's start with the reactive programming first. Usually when I introduce reactive programming, I tend to explain a little bit about the different programming paradigms. So as you know, we have imperative, functional, reactive, many others. I don't think that this audience, it's important to explain exactly what imperative and functional is, because you're using that every day, but it's interesting how reactive fits inside the two. And the interesting bit is usually when you work in functional, you work in imperative, you tend to have a unique coding style, and you work mainly with functional programming. You work mainly with imperative programming. If you mix the two, it could be very confusing on your code. But reactive programming is changing this paradigm. So reactive programming can be used with imperative. There are some implementation of OOP reactive, for instance, that are quite awkward in my opinion, but there are. There are a lot of implementation of functional and reactive. For instance, cycle is one of them, SAM pattern as well. But the interesting bit of reactive is that you don't need to work only reactive paradigm, but you can use reactive on existing projects. So also if you can get the benefit of reactive programming, not only on brand new projects, but also on existing projects. The interesting bit of reactive programming, as we will see in a moment, is the fact that it's taking into consideration another dimension that before wasn't taken into consideration, that is the time. And usually when we talk about front end, time is something that we used to deal with. One thing that I notice often when you speak with front-end developers, we're used to work everything asynchronous, and when you speak with back-end developers, in particular in the last 5 years ago, for instance, it was very awkward when you start to talk about asynchronous stuff, because they were used to working mainly synchronous. And often they lose themselves around the madness of asynchronous and how to follow a specific thing. So that was reactive programming is bringing that forward, and it's nice because it can be applied basically everywhere. So when we think about reactive programming, we need to have a distinction between interactive and reactive. So usually when you do interactive and you describe, let's say, something interactively, you have two objects, let's assume A and B, and usually A knows how to use B. And that's the thing where it starts to break the paradigm, because it means that if you change the contract with B, it means that you have to change on all the A's that are using B. That's something that we try to mitigate in several ways, but often this is not possible, and that is going to create some problems. Instead, in interactive programming, reactive programming is completely the opposite. So you don't have to know what is, let's say, how B is built or what is hidden behind B, but you just communicate that something changed, and B is reacting to that. So with the standard contract, you're just describing how these two objects are communicating, and these two objects are completely unaware of the other, and that's the nice thing. Usually you always have, let's say, a third object in the middle when you work fully reactive, and you tend to have something that is decoupling completely the existence of A and B. And that's very handy, because it means that if you try to refactor A or B, the other doesn't need to know, and you can work in parallel. So if we take that in an example, for instance, we can have this simple example where we have a calculator under C. And when we have an interactive implementation and we instantiate the calculator and the receipt, when we inject the calculator inside the receipt, there, what we are doing in the receipt, we have this print method that knows exactly how to use the calculator. Therefore, if I change anything about the calculator, either the arguments or something else, this function has to be changed in any place that I have to do. And also, I interactively know that, so I know exactly that I have to use some or any other property, and I have a clarity on how these objects are working together. Instead, if I move to a reactive one, I don't really need to do that. I have an observable that is a standard contract in this case, and I just subscribe or pass or change something completely independently. I can have one receipt, or I can have many of them. I can pass this observable, and everyone will react to that. And that is basically the concept of I was describing before with object A and object B, where object B in this case is the receipt. So in this case, they don't know each other. They just pass one specific object, is a third object, and they can interact together without any problem and without knowing each other. So if tomorrow I create another thing that has to subscribe to observable, create another output, I don't have to know how calculator is managing that. I know that I have this standard contract, I can use that. So that is a brief introduction on reactive programming. But when we talk about architectures and how the reactive programming fits on that, we need to start from the beginning. So we need to start from the 70s, honestly, where MVC was born and was created. MVC was the first formal architecture that we use as Smalltalk in like quite a few years ago. The interesting bit is that it started to divide, let's say, a software in multiple pieces, where we have a model where we store some data, we have the view where it's rendering some data, controller is controlling the 2 bits. From that point, MVC evolved a lot, obviously. In this case, for MVC, for instance, usually you can see mainly two implementation. Depends from the language. It depends from the age when you want to see, because there was a version that was created in the 70s, another version that was created in the 80s. In both of them, the controller is basically the orchestrator. In one of them, that is the one of the 70s, the model was calling an update on the view in order to update the view when it was ready. But overall, let's say, the logic was, let's divide the software and the complexity in specific domains, so when now something is changing, I know exactly where I have to change, to put my hands. Okay. And then we have, in the 90s, instead that evolved in MVP, that is Model View Presenter. Model View Presenter is personally my favorite architecture. The interesting bit there is, again, we have a model where we describe, we store the data, we describe the state and everything. We have a view that usually is a passive view, and in the case on MVP, the passive view, what it does is literally, let's say, waiting for someone, in this case the presentation model, that is calling a method for re-rendering or whatever it is. Currently, all these things are quite common because we're using React, we're using several stuff, but currently think about that in the early 90s. It's a completely different thing. The interesting thing of MVP is that there is a strong relation between the presentation model and the view, and usually the relation between the two is always one-to-one. So usually when you create a view, you create its own presentation model, and the presentation model can manage just a view. And that's very interesting because in particular on that time, what you can do, consider that you have a passive view that is completely unaware of what's happening inside the system. Someone is calling and just saying, do this. The interesting bit is that you can change the views at runtime. So basically you keep the behaviors, you keep the state totally away from the view, and you can change the view at runtime. With MVP, personally I created several projects, and for instance, just to give you an idea, when I work on a desktop project with an architecture made based on MVP, I was able to port 90% of the code on mobile without changing anything. Obviously, I had to tweak later on stuff, but I just changed the views. The interface was completely different from desktop and mobile, direction completely different, but the behaviors and the state was exactly the same. That was really cool. And then in 2005, Microsoft came up with another architecture, MVVM. that stands for model view view model. And this is very similar to the MVP one, but oh yes, one thing that is important to highlight here. If it's an MVC, there could be the model that could know about the views. In MVP and VVM, the model and the views are completely unaware of their existence. So there is an object in the middle that is completely decoupling these two entities. In MVVM, though, there is a slight change. So if before we had a passive view, the view became more smart. And the view model, what it does is a sort of controller, but the difference between the controller on the MVC and the view model on MVVM is the fact that the controller on the MVC doesn't store any data. So it's just saying, it's just updating the view, updating the view or updating the model. And it's just bridging the data between one place and another one. In MVVM, instead, the view model, first of all, can be the view model of multiple views. It's not a relation one-to-one like MVP. And the other interesting thing is that usually a view model gather all the data that needs from the main model, and is basically manipulating temporarily the data and then store the data finally on the model only when they need to be shared across the entire application. So the view model de facto becomes a sort of temporary model that will that allows let's say the view to be updated and to have an interaction between the views. The other interesting bit is that we are reversing the knowledge, let's say the link between view model and the view, because finally the view can see the view model. Instead on MVP, the view was completely unaware of the presentation model, and presentation model was orchestrating the view. That was a big change. It was used on several other languages at the moment. Then in 2009, we had DCI that stands for Data Context Interaction. It was the same creator of MVC that said in 2009, MVC is an old architecture, it was working perfectly, but it was missing something. And basically DCI is one of the most famous lean architectures for software. The interesting bit of DCI is the fact that it's completely changed the way how we are discussing. If before we were discussing on more on hardware level, so we have the model where we store the data, the view that we want to describe. In the data context interaction instead, we are talking about business. So basically, data context interaction is an architecture that create a context and inject the data and interactions. The interactions are completely unaware from the context, and they are reacting to the context. So basically, it is based on the fact that you are describing a specific scene, a specific scenario that is the context, and then you inject some data, you inject some interaction. They can compose together because are completely side effect free, and they are defining this context and interaction between the twos, just injecting inside the context and data interaction. It's an interesting one. I've never seen that in production, to be honest. I saw a lot of languages that are implementing that. In particular on the client, I see a Hex implementation, a JavaScript implementation, an ActionScript implementation, but I never saw a lot of traction. It's very, let's say, leading on the mindset, a lean mindset, if you are familiar with that. And then suddenly in 2013, we started to have Flux. And I think Flux, you are all familiar with that. But the interesting bit of Flux, often we refer to Flux to the framework, but Flux is a pattern. And the main thing that is bringing on here is the fact that in order to scale up with a ridiculous amount of developers that has to work together, Facebook came up with a unidirectional data flow that allows basically to segregate each single logic in specific things like action, store, and the things that we are very well aware nowadays, but in a unidirectional flow. Before we always had, let's say, an interaction that could be bidirectional between view model, and all the other architectures. Finally, we start to have a unidirectional flow, and this is a main characteristic on reactive architectures. All the reactive architectures that I work with are all following the Flux pattern, and all the new, let's say, the latest front-end architectures, I would say, that are reactive or not. So in 2015, we start to have a revolution on architectures. The first one that I'm going to present is the model view intent. Again, we are moving from model view that I think we are very familiar, but we had a third thing that is intent. But in order to explain that properly, we need to understand the concept of stream. So a stream basically is a sequence of value that are happening in a certain period of time. So again, reactive programming is bringing the time as a key thing. And the interesting bit for understanding stream, so usually when we talk about observables, and I did several interviews and they talk about observer pattern and stuff like that, a lot of people are always thinking straight to RxJS. And the problem is RxJS is just, let's say, a tool to express this thing, but a stream is a concept that is behind and way above RxJS. So if you understand the concept of stream that is composed by a producer and a consumer, you can master not only RxJS, there are many out there. There is FlyD, there is Xstream, there is Most.js, there are tons of other libraries that are exactly following the same logic. But the thing is, often we focus too much on the code and too much on the implementation of the code instead of understanding the concept that there is behind that. So in this case, for instance, these are, if you are familiar with the marble diagrams, and in reactive programming are very used to describe what's happening. So usually there is the expression of the time in this horizontal line, and when the stream is complete with the vertical line, if there is an X at the end of the line, it means that an error occurred. And basically here we can pass in a certain amount of time by interaction, or because we are fetching data from a data source. We can pass inside this stream some data like 4, 1, 3 in different time. We can also manipulate that. So we can also add some operators, like in this case map, that are, every time that we receive a value, we are generating another stream that has a converted, has a manipulation of the data that are flowing from the initial stream, from the producer basically. And this is allow you, as you know, to avoid the side effect inside the application, and you encapsulate perfectly and describe how your data should flow inside your application. But that is not only for, let's say, a small amount of data that is an operation that is happening in a specific function, but potentially you can use this also for communication across multiple parts of your application, like MVI is doing. So MVI is exactly this description here. It's a unidirectional data flow. Is composed by model view intent. In this case, we have also the DOM, and I explain in a moment why. So, for instance, in this architecture, what we have, the DOM is the representation of the view. So what the browser is rendering there. And usually, when we have this, we need to listen to some user interaction, for instance. The interesting bit is we are capturing this user interaction in the intent. So the intent represents what the user would like to do with the views that is in front of it. And what it's doing is just capturing this information. It could be like a drop down that changes the value. It could be like someone that click a button, wherever it is. And is passing this information to the model. The model is reassessing the state. And the state is, let's say, every time that is updated through, because each single communication is happening through observables, what is happening is that the view is subscribed to the model, so let's say, to the observable of the model, and the view is just preparing through the virtual DOM what is the next state. And then when it's ready, is updated the DOM. So as you can see, there is a clean separation of concern here, because we have an intent that is just wrapping the intent of the user, the model that is owning the state and is, let's say, managing the state for the application, and we have a view that is basically preparing the data that will be rendered later on set DOM. The interesting bit of this, that is for me the most interesting part, is that this architecture can be part of a fractal architecture. So what does it mean is that basically you can have a component that is composed by this architecture and have another component that's living inside the same application that is exactly with the same architecture. And because it's a fractal, potentially could be replicated across the entire architecture, working components by components with that specific architecture, really, really small. And the components can be let's say, like a tiny component that is doing just one thing. It could be an entire view, it could be an entire application that you mix and match with another larger application. So the nice thing of this is that you can use this thing and represent in a fractal way. we know that there is an interaction from the DOM. There is captured by the intent. The intent is passing this data to the model. The model is re-updating the state. The state is passed to the view that is preparing what it has to show through the virtual DOM, and the virtual DOM is the way that then is updated the DOM. That's how MVI is working. So if you want to summarize, each module shouldn't control any other module. All the communication are happening through observables. The only shared part are observables, so they don't know each other. So the model view intent, they have no clue that there is an intent function, there is no clue that there is a model function, there is no clue that there is a view function. The only thing that they know is that they have as input an observable and as output another observable. That's how it works. Then the intent is the part that is taking care of let's say is interpreting what the user is trying to do inside the application. That's the main thing of the intent. Again, characteristics are unidirectional flow. There is strong separation of concern. Communication between objects is just by observables, and is part of it could create a fractal architecture. So in fact, if, for instance, if you work with Cycle.js and you have you create an application or a view, and then you want to put in a larger view, it's literally a matter of a few minutes in order to have a nice and clean implementation of your stuff, because basically you have multiple unidirectional data for MVI architecture that are working together. The interesting bit is the MVI is in a certain way, it's not called MVI, but with the similar concept is used also in Elm. So if you're familiar with that, you can use with Elm. For instance, I tried to have a stupid exercise to use Cycle and Elm together, and with interrupt from JavaScript communicating between the two. It was really nice because basically it's a unidirectional flow also on the other one, and Elm is very, very similar. In fact, Cycle.js and MVI was inspired by Elm. Cycle.js is using that and works with mainly the pure function and encapsulated the side effecting drivers. In Cycle, usually what you have is you describe your application as a pure function, and when you for instance, rendering the data inside the DOM is considered a driver, or an HTTP request is considered a driver, because it's a side effect that is not fitting inside our let's say the Cycle flow. A very light framework. Cycle doesn't impose MVI, so you can use Cycle in procedural way. You can use with MVI. You can use with MVI in a more complicated way. There is, for instance, Onionify, that is one of the libraries that are available in the Cycle environment. It's pretty interesting. Currently, I think recently they released a new version of Cycle. There is also a conference, Cycle conference in Denmark, that is happening every year. So if you're interested in that, you can go and check. Another one is Mobec state tree. I will go very fast on here. So usually when you think about Mobec state tree, there are four key things that you have to take into consideration: observables and observer, computed values, reaction, and actions. Observables and observers, we saw what they are and how they work. Computed values are a pure function that are deriving complex values. So for instance, in Mobex, we have these computed values that are really smart for the main reason that you can have, let's say, a complicated value calculation that you have to do. Mobex does the first time the calculation, then it is basically memorize the final value unless some value inside the calculation is changed, and therefore is going to update the request. Reaction are used for encapsulating side effects, and action are used every time that the user is interacting with our view. So usually when Michel created Mobec state tree, the idea was mainly to mimic what you can have inside the DOM. So if you think about visually inside the DOM, you have like a tree, and with Mobec state tree, the idea is creating another tree that could be, let's say, pairing and balancing the other tree of the DOM. So you have a tree for managing the view, and you have a tree to manage the behavior and the store and the state. And that's honestly a good idea. It could be that there is a relation 1-to-1 between the store and the views, but it could be the relation could be 1-to-many. It's completely up to you how you structure your Mobex application. So if you think about Mobex state tree in action, we have the view that is interacting. So every time the user is interacting with the view, they dispatch an action. The action is updating the application state, and automatically, reactively, is changing the computed values and updating the views. So that's the part that here is reactive. It is basically everything. Every time that you write something in the model, you are basically these properties that you describe inside the model are converted through proxies in observables. And the nice thing is every time that you change anything, because these are observables in the computed values and in the views, we are observing these changes, and every time there is a change, automatically, boom, the view is updated, and you don't care about this part. So basically what you code every time is just this part here, and you forget about the rest. And that's really nice because basically it's hiding the complexity of reactive programming in imperative implementation. So the stores and view don't be related one-to-one like MVP. It's more, let's say, an MVPM integration. We can hide in the reactive part in imperative code. In fact, one thing that I used to say is start every time with MobX state 3 if you want to embrace reactive programming, mainly because it's the easiest way to start with reactive programming. You won't notice that. And when you want really to feel the reactive pain and joys, move to Cycle.js. The interesting thing is that our trees are immutable. Therefore, automatically the framework behind the scene is creating a snapshot on how is the state of the application, is serializing that, and potentially we can save on the local storage or wherever we want. There is a type system check at runtime, really like that. That was made by a guy from Italy. I met him, pretty smart cookie, did really great job on that, and we can create not only primitive, we can also, we don't have to create only primitive object, but we can have also complex object like, I don't know, array of specific objects and stuff like that. That is really a nice implementation. The other thing that you can have is the store can have lifecycle hooks that could be either patches or snapshot hooks. And we can hook to them and apply some logic. So every time there is a change, we can, for instance, store the snapshot on the local storage or understand what change happened in order, if you want to create, I don't know, a memento pattern where you are storing, you are doing undo and redo of your UI. It's easy to approach. It's definitely very opinionated. There are clear boundaries on how to use it. It's not like MobX that provide probably too much freedom in order to create a full application, but it's still, let's say, useful for creating prototypes. There is tab checking at runtimes. It works very well with virtual DOM libraries. So for instance, if you want to use, if you don't want to use React, you want to use another VDOM library, you can do with MobX, no problem at all. Works pretty well. It's really smart the way how he's using composition and dependency injection for the tree part, because we can compose our trees. We can have a unique tree that is composed by multiple trees. It's really interesting how it was architected that bit. And dependency injection obviously is a mechanism that we know very well. And we end up with the SAM pattern. SAM pattern is similar to MVI. So in this case, what we have is again a sort of model view intent, but in this case we have a view that is a real view with the DOM. Every time that we interact with an element, we basically dispatch an action. The action is preparing the data for the model, and that's very important with, let's say, highlighting preparing, because the model exposes just one method is present. And basically, when the action is presenting this data to the model, what the model can do is rejecting the data, say, I don't know this data, so I don't store anything, I don't change the state. Or it can just take this data and change basically the application state and move forward. That's an interesting bit, because usually up to now we always say that imagine that like right now we are working on a large application, and you can start to see, maybe we divide it in different domains, but let's assume that we share the entire application, that we have this architecture here, where someone is taking care about the model because it's very complex, covering everything, and other teams are taking care about the action, the view. So that in that case, for the first time in an architecture on the client, I see, let's say, a possibility to reject the data going to the model. That's an interesting pattern. I'm not saying I'm a big fan of it, but it's something new that I never saw before. The model is preparing the data for the state. The state is basically the representation of the virtual DOM. And then the virtual DOM is passed to the view. The interesting bit of SAM is that you have an additional thing. So when you prepare the state from, when you prepare the virtual DOM from the state, what we usually do is also calling again another action, because you know, every time that you change the view and you want, for instance, you have dynamic data and you want to show the initial view with highlighted the first element, for instance. Usually that thing in SAM are handled at this level here. So usually what you do some hooks, like you want to understand when, I don't know, the data arrived for the first time, and by default you highlighted the first element. But often I saw some implementation that you don't really know where to put this data. Where is the right place where you are just calling, okay, now highlight the first element. In this case, SAM provides this possibility that when a state is updated, you can dispatch another action to say, okay, highlighted something else. And that's pretty brilliant, because this characteristic is often is happening very often in any application. So that's a good way to handle this. So again, how it works: interaction from the view, dispatch of an action, update of the model, if feasible, passing the data to the state. The state is preparing the virtual DOM, dispatching of another action if need anything, and therefore is doing again the same flow, and then the view is updated. So that is another way to do that. Again, unidirectional data flow. All the actions are pure functions that are basically that translated the user intention to the model. The interesting bit is the view. The view is basically representing a function where we inject the model, and that's it. So in fact, if you see the implementation of SAM pattern, what you have is literally, you see on the view that there is an injection of an object that is a JavaScript object, and the view can be represented. That means this is to test. So if you want to test a view in SAM, it's really, really simple to do that. The model is a single state tree and exposes just one method, that is present. So you don't access to a specific information, but you literally have just this present. So an action is calling every time model.present. And inside there is passing an object, and the model can reject or not the data that is received. The state is defined in the virtual DOM that then will be used in the view for representing the UI. The interesting bit of SAM is bringing a strong separation of concern, is based on pure functions, is providing single responsibility, so each single component of module should be responsible for a specific feature. So as we have seen till now, there is a very well encapsulated logic for each single element. So if we work in, I don't know, 10, 20 developers on the same project, and there is a problem on how the state is rendered, we know exactly where to go, and there isn't that you have to start with bubble between files and other files, stuff like that. The other interesting thing that is bringing is the list knowledge. So the component should not know about the internals of other components, and it's similar to what we have seen with the MPI. Okay, so it's very similar thing. SAM is framework agnostic. The main implementation that I saw on SAM on JavaScript is on Meiosis.js, that is using let's say this pattern only. But it can be used if you go to, I think it's sam.org, something like that, sampattern.org. You can use, you can see the implementation on Angular or many other React or many other thing. It's favorite composition over inheritance by design. Is fully based on pure function. It's very easy to do test in isolation and debug, because everything is a function and it's a pure function, therefore you can take and test, and there is no problem. And also this one can be part of a fractal architecture. So the question is, after this, which one should we use? And the answer is depends, right? So there are plenty of them, as you have seen. It's important, in my opinion, not to master all of them, but to be aware of all of them. Mastering is another kind of beast, because it means that you have to work month on month and see all the, let's say, blind spot that the framework can provide you. The interesting bit of here is the fact that we have all these possibilities. Potentially some of them could work better when you are in certain environment, like, I don't know, when there are tons of developers. Some others, when you want to prototype, are very quick to use and easy to use. Therefore, in my opinion, usually what I personally do, I tend to understand what's going on and how they work, and then I try different approaches, but it depends from the project and the context, obviously. So what we have seen, so we will talk about interactive versus reactive. We talk about the Frontend Reactive movement. It's just started, it's true, but still it's becoming solid and solid. And we talk about any non-reactive architecture, how it could become reactive. So we saw MVC. All the others, honestly, could be easily became reactive, if not partially, also fully. It depends how you refactor the stuff, but at the end, the nice of reactive programming is that can be used basically everywhere. Thinking reactive requires a shift of mindset. So if you will see that if you try to use Cycle.js compared to Mobile State Tree, it's completely different kind of beast. Mainly because at the beginning, when you do through the small tutorial, everything is fine. When you start to interact and create your own drivers, you start to create, you start to interact with the own Unify, is completely different from, let's say, a more imperative way that you can find in Mobile State Tree. Understanding the different architecture and yeah, the thing that it's important to make to be aware of these things. It doesn't mean that you have to master, but at least you know where to look at when you need them. Everything is available on this book. I think some of you know, and that's really it. Thank you. Cool. On time.
Questions for Luca? Anyone? No, all just sort of blown away.
MVI, I do a lot of work on the Blender open source system plugins. So MVI is really intuitive, and I just can't stress the benefits it brings.
Yes.
For the power interfaces you can design, incredible. And the teams that can work on it can be very intuitive.
Yeah.
So it's good stuff.
Yeah. I agree with you. Personally, it's for a while I work only with that. For at least a year, I worked just with MVI and Cycle. It was really, really cool. Yeah.
Sometimes when I'm trying to work out the complexity of a component, this has that way, that has that way, I tend to write really simple state machines.
Mm-hmm. Inside the component?
No, just on paper.
Okay, on paper, okay.
So it's simple.
Yeah.
State machine. I wonder, you were talking about all these different frameworks, they all work slightly differently. Could you potentially just have a simple state machine which is a standard, and then export that to all different
frameworks? Yeah, absolutely. Yeah. All of them basically are leveraging the same logic, right? Yeah. So you have your own state, and then you update in different ways. So potentially, yes, you can do that. It's not a big deal. The thing is, some of them has some key characteristics, like Sam, he has these quick updates. So for instance, I'm thinking financial dashboard probably could be a good thing, because you have to load a lot of data, you need to react to them, and then you need to highlight something. That could be a good implementation. Mobile State Tree, I think, is really good for prototyping. It's really good for certain kind of projects. Probably because of the fact that you have a tree that you have to manage, it could be trivial if you just create a huge, giant tree that is handling the entire state of a complex application. That could be complicated, but on the other side, it provides you the possibility to split it up in multiple trees, but you need also to maintain them. That's the other thing that you have to take into consideration. Cycle, I think the fractal architecture is an interesting one, because allows you to really think atomically on a specific thing, nail it down, and then think to the next one, and then put together like in a really simple way. I think every time I think about fractal architecture, I think about Lego, because there are small bricks that you put together. Inside the bricks, you have your MVI architecture that is up and running. And it's starting to be used, as Marco was suggesting, in other places, and it is getting a lot of traction. I see in the last year Android developers embracing MVI very often. And it's brilliant because honestly it means that it's just going, that's the nice thing of focusing more on what there is behind the code and understanding a little bit about the architecture or the design pattern behind that, because then if today you're working with that and with Cycle.js and tomorrow there is another framework that's using MVI, honestly it's just you need to learn the grammar, that basically how you write the code, but you have in your mind clear in your mind how it works, and that means probably a couple of hours of investment for you to move from an old framework to a new framework because you understand what there is behind.